So hello guys, as promised in the channel update video, I'm now going to do the teardown video of the ASUS GTX 580 DirectCU 2, and today I'm really going to focus on just giving you the teardown and then the PCB overview without any rambling. At least I'm going to try. So yeah, let's get this started. Here we have the GTX 580 pretty much as you would get it out of the box. The only thing is that I removed the PCI Express bracket here because, as you can see, it is a triple slot one, and I have the card mounted vertically in a vertical mount in my test system, and of course with such a thick PCI Express cover it doesn't fit, so I just removed it. Other than that, the card is pretty much as you would get it out of the box, and yeah, so let's get started. The heatsink is actually pretty modular. You can disassemble it into 3 separate parts. So the first thing I'm going to do is I'm going to remove the shroud of the card. The shroud is screwed in by 4 little screws on the side. So the first one I just removed here. The second one is this one here. And there are 2 more on the other side, and then there are 3 bigger screws under these red accents. These are glued on. You have to pry them off with a little bit of force. Then you can remove the screws under them. I already removed them and I haven't put them back in there, so I'm going to skip this part. Just if you have this card, you want to disassemble it, remember to remove these 3 screws under there. So now I'm going to remove the other 2 screws from the other side. And now the shroud is already unscrewed and we can take it off. Here you can see the screw holes for the other 3 screws I was talking about. So yeah, you have to remove those. They screw into these holes here on the card, so yeah, the 4 little screws are strong enough to keep the shroud on there, so you don't really have to bother about putting these back in if you want to disassemble the card. So now we have the card still fully functional, but without the shroud, just the heatsink and the fans. And running a card like this actually will improve thermal performance, just not by a lot, really. So, yeah. Now the next thing that we are going to do is we are going to remove the fan assembly from the heatsink. So that means the 2 fans and this metal structure around it. The fans are also screwed in with 4 screws, 2 of each on each side. These are pretty large screws, so you can just use a normal Phillips head screwdriver for them. This one here is kinda hard to get out, so I am doing this one first while the heatsink is still in place. And then the other ones are pretty easy to take out. I'm sorry if you can't really see the whole thing. The card is pretty long actually, so there's not this much space between the screw I'm taking out and the camera. So now the whole thing is still in place, and it can actually take yeah, it's pretty hard on. The thing is, because it is a little bit yeah, it is pushed into place by these by these extrusions here. So you just have to press down on one side and then the other one should come off, just like that. And now we are going to remove the main heatsink, because this fan cable is under the main heatsink and we can't really disconnect it without removing the main heatsink. So to do that, we only have to take out 4 more screws. These are the large ones on the back. I would suggest to always unscrew a GPU cooler or anything on a large chip like a GPU or a CPU in a cross pattern like I'm doing now. Note that I'm also not fully unscrewing the screws first, I'm just loosening them and then unscrewing them fully. Why I do that is that I want to distribute the mounting pressure, so the stress on the GPU and the PCB. I want to distribute it evenly because I have seen cards where the GPU was damaged or just outright destroyed by not removing the screws in a cross pattern. So now the heatsink is not screwed in anymore. It's still being held on by just the thermal paste on it, but you can see we can wiggle on it, and with enough force you will get it off. So now we can remove the fan header. Ideally I would advise to just try to do it like that you just try to take out the connector itself and not the full socket, but like you can see here, the socket always comes out with it. It's always a little bit annoying when that happens, because you can stick it in again in the false orientations and your fans won't spin. They won't break, they just won't spin up. So yeah, you might have to take apart the card again. Normally the holes for the fan are closer to one side than the other, so you can kind of see in which way it is going to be mounted, but yeah. So this is the whole fan assembly now, yeah, unscrewed, taken out, and yeah, what you can see about these fans is that they are actually pretty large, and when you power the card on, you will also see that they are very loud and very strong. That's basically because these are just straight up case fans. I measured them, they are 92 millimeters, so they are basically just 92 millimeter case fans on a on this metal construction used for putting them on a graphics card. You can also see that the heatsink is actually not that substantial. It's actually pretty small. It's only a 5 heat pipe heatsink, where only 3 heat pipes go to the right side, and then the two others will stay on the side where the core is at. And yeah, it's actually pretty thin for a card like this that has such a high power rating. So pretty much how this card is kept cool is, yeah, the first thing is just by having the heat pipes directly contacting the GPU, or at least the GPU IHS, because yeah, NVIDIA used to put IHSs on their GPUs. This is claimed to have better thermal performance than non-direct heat pipe coolers, but I couldn't confirm that yet, so I wouldn't really say that it's the reason why this card performs better than the stock card. I think it actually performs better because the fans are just very fast and move a lot of air. So now we come to the PCB itself. We can see the first things already. We have our GPU here, currently still covered in thermal paste. We have our 1.5 GB of GDDR5 memory. On this card, the memory modules are made by Samsung, which you should be able to see in a few seconds. Yeah, there you can see it. There's the Samsung name on there. And we can also see our power delivery portion of the board with the MOSFETs from the VRM still being under this heatsink, which I'm going to remove right now. One thing that is to note about this VRM heatsink is that it's actually pretty nice to have a dedicated heatsink for your VRMs, because you can mount custom coolers or even liquid nitrogen pods on your graphics cards without having to bother, without having to think much about VRM cooling, because this heatsink is still here with this big thermal pad under it. You will still have to point some airflow to the heatsink, but other than that, you pretty much don't have to care about it. So now let's look at the VRM for a bit. We have 10 chokes in total, which would make someone believe that this is a 10-phase VRM. Actually, it's not that easy. We have 2 VRMs actually. One is for the core, the other is for the memory. And we can see here, this is our memory PWM controller. This controls the 2 upper phases here. So we have a 2-phase memory VRM, and then the other 8 phases are for the core. Our PWM controller for the core is also this one here. The exact specs are this PWM controller is an SHE ASP0907. This is a part rebranded by ASUS. They used a lot of international rectifier, but a lot of the other parts of this card are made by UPI Semiconductor, so I would believe that this controller might also be a UPI Semiconductor PWM controller. Other than that, we also have these 4 little chips here, which I first believed to be doublers, but now I believe that they are actually just dual drivers, so 1 driver for 2 phases. Which means that our vCore VRM here is 8 actual phases. In case these are doublers, we would just have a doubled 4-phase. Now the vCore VRM is made up of 2 high-side MOSFETs and 2 low-side MOSFETs per phase. These 4 MOSFETs would be the PH7030AL 76 amp MOSFET for the high side and the PH5030AL low side MOSFET. Our high-side MOSFET has a rating of 76 amps, as I just said. I have this number out of a datasheet that I found online. I can't really say that if this current rating is actually the current rating we will have on here, because I couldn't find out if this current rating is for 5, 10 or 12 volts. So I would guess it is for 10 volts, and yeah, these MOSFETs are probably driven by either 12 or 5 volts. I can't be sure, really. I can't really see a 5 volt VRM here, so they could also be driven by 12 volts. It could also just be on the back side, or I could just be missing it. So yeah, 76 amps is the closest thing I can give you for current rating of our high side MOSFETs. Same as for the low side MOSFETs. These have a rating of 91 amps. Same thing with the voltage applies to these. And they also have an RDS on resistance of 3.6 milliohms, which is, well, it's not the best RDS on resistance, but considering that we have 2 low side MOSFETs per phase and also 8 phases for vCore worth of these, so I wouldn't think that this slightly above average RDS on resistance is really a problem. Also considering that we have a big, nice VRM heatsink here, so yeah, I don't think that the heat output of this VRM will be a big problem. So another thing about this PCB is that ASUS actually chose to use fuses. So there's 1 fuse here, and there are 4 more here. These are all 12 amp fuses, and if I remember correctly, at 12 volts, these fuses would allow a total power consumption of 576 watts. I don't know if I put this into the calculation as well, so I actually don't remember if it's just these 4 up here or also this one here that allow for a maximum theoretical power consumption of 576 watts. I don't think that I will ever hit this power consumption, not only because my power supply only has 750 watts, it's also because I don't think that I will be able to cool 576 watts of power consumption. So yeah, I guess we will never really reach the theoretical maximum power limit of this card. So now I'm going to take off the thermal paste from the GPU so we can take a look at it. So the GPU is now mostly cleaned, and here you can also now see, if the camera decides to focus, yeah, now you will be able to see that our GPU on here is a GF110-375A1. This is a fully unlocked Fermi GPU. So as the name implies, it's based on the Fermi architecture. This is actually the second time that NVIDIA used the Fermi architecture for their consumer graphics cards, with the predecessor being the GTX 480, which used a GF100 GPU, if I remember correctly. The GTX 480 GPU had 385 CUDA cores, while as this has 512. So there's quite a bit of extra calculating performance that this GPU has, but it also comes with the usual Fermi traits, meaning that the power consumption of this 45 nanometer card is very high. So yeah, not only do we have the 576 watt power limit, we also have our two 8-pin connectors over here, which are definitely needed for this card. And yeah, this pretty much is everything I have to say about this PCB. I'm not going to take off the backplate because I already looked under it and there's not really a lot of interesting stuff behind it. The only thing of note on the back is actually this black box here. This is a capacitor and it is a Proadlizer, if I remember the name correctly. And this Proadlizer capacitor is just like every other capacitor, just that it is very expensive, very large, and it has a very good frequency filtering response across the whole frequency spectrum. So basically what these capacitors you find on the backs of GPUs are for is, depending on their size, they are good for filtering certain frequencies, like switching noise caused by the VRM. And companies put these capacitors back there to filter all the switching noise, and what ASUS chose to do here is replace all these smaller capacitors by this big one, which has really good frequency response across the whole spectrum. Now, yeah, this is pretty much what these Proadlizers are intended to be used for, but actually I only ever saw them on one other card, being the Gigabyte Radeon HD 7970 Super Overclock, or SoC for short, where they used 5 of these just strapped to the VRM, which was probably because AMD didn't allow them to put them here where ASUS put this one Proadlizer, because this is actually where they are intended to be placed. Now, why don't we see this today? It's probably for the same reason why Gigabyte put them on the back of their VRM. It's because NVIDIA and AMD probably don't really want board partners to mess with their capacitors on the back of their GPU. Like, if you look at several GPUs, they will almost always have the same setup of capacitors at the back of the GPU, which is probably why because AMD and NVIDIA don't allow board partners to change anything about that region of the PCB. So yeah, that's not really it. I don't really have to say anything more than this. This is the ASUS GTX 580 DirectCU 2. I gave you a quick overlook over the PCB. I showed you how to disassemble the cooler of it. Yeah, so this is pretty much everything I wanted to do with this video. And I hope you enjoyed watching this rather short and not that much rambly video. So I hope we can see each other again in the next video. Until then, bye.